All right, so what I'm going to do in this particular video is I just want to explain something that is a part of math that you probably have learned about, but there's a very good chance that where that thing came from or what it means was never explained to you, okay? So I'm not going to tell you what it is until near the end, okay? But it has something to do with circles. And what we're going to say here is that this is a circle that it doesn't matter what the radius of the circle is, but let's just say for the sake of argument, we're going to say that the radius of this circle is 1. Okay, so this has a radius of 1. 1 what? I don't know, let's say 1 foot, okay? So the distance from here to here is probably about 1 foot. So here's a circle with a radius of 1 foot. Now the foot doesn't matter. Just the fact that it has a radius of 1 does matter. Now what I've done here is I've taken a bunch of paper clips, little paper clips, okay, and I've chained them together, okay? And so what's interesting about this chain of paper clips is that they are equal to the radius of this circle. So I've put a magnet here on the middle, and I've put a magnet at a point on the circle. And so like if I put that one end of the paper clips there and the other end of the paper clips here, you can see that the radius of this circle is equal to this chain of paper clips. Okay, so we have a circle with a radius that's equal to this chain of paper clips. And now what I'm going to do is I'm going to take the radius. Okay, so this chain is equal to 1 radius of this circle. And what I'm going to do now is I'm going to use the radius of the circle to measure the outside of the circle. Okay, I'm going to measure the I guess you could say it's the circumference, but some might call it the perimeter if they're not as familiar with circles, okay? And so what I'm going to do is I'm actually going to put a bunch of magnets along the circumference of this circle, okay? And here's what I'm doing is I'm measuring the circumference of the circle in terms of the radius of the circle, okay? So, and I'm going to start measuring right over here. So I'm going to put the end of the radius here, and then I'm going to sort of try and put it on the magnets as we go around along the outside of the circle, and it's going to end right about there, right here, okay? So you can see that this radius, the length of the radius, is being put along the outside of the circle, and it stops here. So right here, we're going to call that this distance along the arc. This is called an arc. When you do a portion of the circumference of the circle, it's called an arc. So the distance from here over to this purple mark here is 1 radius. That's 1 radius. The distance from here up, and this is at the sort of at the farthest right side of the circle is where I started, okay? And now I'm going to leave that point right there, and I'm going to take the radius off. Oh, I just lost it on, I've got to relink the paper clips. And what I'm going to do is I'm now going to move the magnets over here, but I'm going to leave that one that's right there at the beginning of, or at the end of the 1 radius, but it'll also be the beginning of the 2nd radius, okay? And so I'm going to start the next measurement at the same place where we stopped, and I'm going to move it right along the circumference of the circle. So this is another arc. Now the length of the arc from here around to here is another radius, or a 2nd radius. So the distance from here all the way around to this point would be 2 radiuses, right? So I'm going to put a little mark here. We're going to say that that is 2 radiuses. Now, radiuses is not the right, that's not correct, that's grammatically incorrect. Technically, it's called radii, okay? So I'll put that right here, but I really don't care what you call it or how it's spelled, as long as you get the idea that it is 2, it is a radius and then another radius. The length of the radius of the circle and then the length of the radius of the circle again, so that there's 2 of them, okay? Now I'm going to do it again. I'm going to leave that magnet, whoops, I'm going to leave that magnet right there. I'm going to pull the radius off here. And I'm going to move the magnets over again. Okay, move the magnets over. And then I'm going to put remember, this is the length of the radius. I'm going to start it here, and I'm going to put it around the circumference of the circle again. And it looks like it's going to go right before the halfway. Oh, I should have put them farther apart. This is getting sort of messed up. Sorry. Now let's lay it down again. So put it here and there. Remember, we're just tracing around the circumference of the circle. We're doing another arc. Okay? And so now from here to here is 1 radius. Then from here around to here is 2 radiuses, or radii. And then from here, then we go 1 more radius to here. So that's 3 radiuses, or 3 radii. It's going to be right about there. Okay, so 3 radii or radiuses. Really don't care what you call them. The idea is more important than the word. Okay? And so here's the interesting thing. We could measure a 4th radius, but I'm not very concerned about the 4th radius. Here's what I want to tell you. We can't do this terribly precisely, but what I can tell you is that if we went a little bit more so that we were at the halfway point, okay? We started over here. This is where we started, okay? At the kind of the farthest right. And this point right here is exactly halfway around the circle. 1/2 of the total circle, okay? If we were to measure with this thing again, okay, from here, to go from here to here, this distance right here, that distance is approximately equal to 0.141592 of a radius. Okay, ... It's actually a really long decimal. It's a continuing decimal. It never ends. Okay, it never terminates. Okay, and so if we were to add up the distance along the circumference, starting here and going 1 radius, 2 radiuses, 3 radiuses, and then stop at the halfway point here, it would actually be 1, 2, 3 plus this little bit here, which is 0.141592. And so the distance around to here is approximately equal to 3.141592 ... which you probably already know and understand as pi. Okay? And so that's what we're doing here. We're trying to understand pi. So maybe you never understood where pi came from. Like you used pi in formulas, right? And you've been told that pi is an angle measure that happens over here. And there are lots of things that you've probably done with pi. But the question is, do you understand that the reason we have pi is because if you take the radius of a circle and use the radius as a measuring stick along the outside of the circle, you will go halfway around the circle at approximately 3.141592 or at pi, which now explains why circumference of a circle is 2 pi r. Because if we go halfway around the circle, that's 1 pi. But if we continue from here and go the rest of the way around the circle, that's another pi. That's another 3.141592, etc., etc. So that's 2 pi when you go all the way around the circle, 2 pi. So now around here, this would then make to 2 pi. And depending on the size of the circle, you would then multiply 2 pi times the radius that you are measuring with. Now in this case, we said that this was 1 foot, right? So we would do 2 pi times 1, which is 2 pi. But if you were to then change the units of measure or change the size of the circle, change the radius. For example, in this case, we used 1, 2, 3, 4, 5, 6, 7, 8, 9. We used 10 paper clips. So even though it's 1 foot, we could say that it's either 12 inches. We could also say it's 10 paper clips. So if you wanted to identify the circumference of this circle, it would be 2 pi times 10 paper clips, in which case it would be 20 pi paper clips. And I don't want to confuse you with the changing of the units, but I just want you to understand, where did pi come from? Pi comes from the idea that you are measuring the outside arcs or arc of the circle using the radius as a measuring stick. When you do that, it is called measuring in radians. Measuring in radians. The unit of measure is called radians because it comes from using a radius, and therefore, from here, from the starting point here to halfway around the circle is pi radians. And then all the way around the circle is 2 pi radians. And if you want to take it one step further, you know that halfway around the circle is 180 degrees, which is why 180 degrees is the same thing as pi radians. And if you go all the way around the circle, we know that that is 360 degrees. And therefore, 360 degrees is the same thing as 2 pi radians, which is probably a conversion or a relation that you have seen in your math class at some point, or if you haven't seen it, you're going to see it very soon.